Hello, let's talk about homework 7, game 3. Start by, of course, looking for dominant strategies. Lefty. If you were to go up, you'd get 8 or 9. If you were to go down, you would get always less than 8. So going up, always better than going down. That means we can put a D here. Righty, up 1 or 0, down 0 or 7. No dominant strategy, right? It's possible up is better than down. Up could go to 1, down could go to 0, but it's also possible down could be better than up. If down goes to Y, it's definitely better than up. All right, player 2, you're told up. If you were here, you'd want X. If you were here, good, you'd also want X. So we have a dominant strategy. And then down. If down is played, player 2 knew she was here, she'd want X. If she knew she would here, she would also want X. So dominant, dominant. We figured out 3 of our 4 pieces for this puzzle. And then finally, what should righty do? Given that righty now knows exactly what player 2 is going to do. Well, obviously, righty will go up because this 1 beats this 0. So now finally we circle the outcomes. Nature goes left. We go up. We go X. And we are here. If nature goes right, we go up. We go X. And we're here. So in this equilibrium, 50% chance we end up here. 50% chance we end up there. Let's go on to game 4. Game 4. Start, as always, looking for dominant strategies. Up could give you 2 or 2. Down gives you always more than 2. Okay, right. If you are a righty in your player 1, up gives you 7 or 6. Down gives you 8 or 9. So down is always more. Dominant again. You know what? I made a dumb mistake, didn't I? I am sorry. But why did I circle up? That doesn't make any sense. Down gives you 8 or 3. Up gives you 2 no matter what. So obviously, down is the dominant strategy. And then what about right? Did I get that one right? 8 and 9 are both better than 7 and 6. So, okay, sorry about that. Hopefully you caught that mistake. See if I can justify not deleting that part of the video and starting over, because if I occasionally make mistakes, you will pay more attention. And if you're like, I don't quite get this, you'll think about it and, wonder, wait, is he wrong or am I wrong? All right. So, lefty goes down, righty goes down. What about dominant strategies for player 2? If player 2 knew she was here, she'd want X. If she knew she was here, well, I don't know. You're indifferent. So it's not dominant, right? Because dominant is always better. If player 2 is certain she's here, I can't say if she'd pick X or Y. So X is weakly dominant, but that's not what we're going to look for right now. What about player 2 if down is played? Well, X gives you 5 or 0, and Y, if you were to play Y, you would get 0 or 1. So again, we can't really be sure, because if you were here, you'd want X. If you were here, you would want Y. So we've got to go to the probabilities. We've got to say, okay, player 2, you're told down is played. Which do you prefer? If you go X, you get 5, 10% of the time, and 0, 90% of the time. So that's basically 5 times 0.1 plus 0 times 0.9, and that is, of course, 0.5. If you play Y, you get 0, 10% of the time, and 1, 90% of the time. So that is 0 times 0.1 plus 0.9 times 1, and that's 0.9, and that is better. So here, here. Now we've got to figure out what to do here. And I'm just going to say I don't know, because, I mean, it does make sense, right? I mean, if you're here, you'd want X. If you're here, you don't care, so why not X? But what's your belief if up? If you see lefty and righty have dominant strategies of down and you're certain everyone is rational, what are you supposed to do if up is played? You're like, my theory of how the universe works is broken. I'm confused. You know, plus how can we exclude the possibility that you're certain you're here and it should be Y when you expect to never be here? I don't know how to formulate player two's beliefs if up is played, because the beliefs are based on thinking the other person's rational and being certain of that. So I'm just going to put, I don't know, question mark, but I can circle what will happen in the game, right? Nature goes left, we end up here, and if nature goes right, we end up here. So I don't know what'll happen if up is played. I don't think up will ever be played, so I'm not too worried about it. If down is played, I think I'll end up, down will be played. So I expect 10% of the time we travel this path, 90% of the time we travel this path. Let's do video 5. Change the clipboard. Okay, video 5. This is not video 5, this is homework 5. So, dominant strategies. If up is played, it's 7 or 0. If down is played, guaranteed 1. No dominant strategy. What about for righty? Up gives you 2, down could give you more than 2 or less than 2. Again, no dominant strategy. Player 2. You knew you were here, you'd want Y. You knew you were here, you'd want X. No dominant strategy. What about for down? If you knew you were here, you'd want X. If you knew you were here, you'd want Y. Uh-oh. Absolutely no dominant strategies in this game. We've got to start taking a chance. We've just got to start drawing triangles and squares around things to see what can work out. But let me give you a bit of a hint. I would start with what lefty will do because of this 0.9. So you see the payoffs for player 2 are kind of symmetric, right? 0, 1, 1, 0, 0, 7, 6, 0. So you're player 2. You're going to say to yourself, when deciding what to do, I'm going to care about what I think lefty is. Because, like, say up is played. You're player 2. You're going to say to yourself, if I think it was just lefty who went up, that would tell me what I wanted to do. But if I think it was both lefty and righty who would went up, I'd respond optimally given if it was just lefty. So really, what player 2 is going to do is really going to be driven by lefty. That's going to be more important than what righty does. So it's easiest to start with lefty because this is just so important. This 0.9 means from player 2's thinking process, this is what lefty does is 9 times as important as what righty does. So let's just start with lefty and let's look for an equilibrium in which lefty goes up. Again, I'm not saying lefty will go up, I just want to consider what happens. Well, if lefty goes up, player 2 in such an equilibrium would say just lefty, and then I want Y. If it's a separating equilibrium, you'd want just Y. But what if it's a pooling equilibrium? If both lefty and righty went up, you're still, because at this 0.9, you're going to want Y. So in an equilibrium in which lefty goes up, it's going to be this Y and this Y. Now, what if down is played? What if, in this equilibrium? Now, what about, we don't have to go any further, do we? Because player 1 is going to regret this equilibrium. Player 1, if he's a lefty, knows down gives an automatic 1. So this can't be an equilibrium. There can't be an equilibrium in which lefty goes up. Because, if lefty goes up, player 2 will respond to up with Y. We know that before we even figure out what righty is going to do. So up is always going to lead to Y. An equilibrium with up, it'll have to be a Y here. But player 1, if he's a lefty, is not going to be happy getting 0 when gets a guaranteed 1 if he goes down. So this is not an equilibrium. So I've just proved there's no equilibrium in which lefty goes up. Let's consider the other possibility, right? Because every equilibrium, either lefty is going to go up or down. So if I can get to all the possible cases if I consider both. Okay, now if lefty's going to go down, we know exactly how player 2 is going to respond to down. Because player 2, if lefty's going down, is saying just lefty goes down, at which point I want X. Or both. But, given this 0.9, I mean, if both are going down, you'll say if I get X, if I played X, I'd get 1 90% of the time and 0 1 10% of the time. Whereas if I played Y, I would get 0 90% of the time and 1 10% of the time. So obviously, if both go down, player 2 wants to respond to down with X. And if just lefty goes down, you'd respond to down with X. So this really means that if in an equilibrium in which lefty goes down, you are going to respond down with X. Now, knowing this, an equilibrium in which lefty goes down, you get X. This also means that we know what righty's going to do. Because if righty knows down is leading to 1, righty is definitely going to go up. And then the final piece of a puzzle is what does player 2 do if up is played? Well, we know that because this is the triangle thing is a separating equilibrium. So in the triangle equilibrium so far, if this, and this are true, player 2 in this equilibrium, if up is played, will know that she has to be here. And if she knows she's here, she wants X. So again, I've not showed this triangle equilibrium is an equilibrium. I've just shown in an equilibrium in which lefty goes down would have to be, this has to be true, this has to be true, and then that has to be true. Now we need, excuse me, to go through all 4 cases and see, does anyone regret? So do people regret the triangle equilibrium? Player 1, you're lefty. Down is giving you 1. Had you gone up, you would have gotten 7. Nope. You regret. So there's no equilibrium in which lefty goes up. There's no equilibrium in which lefty goes down. There is no equilibrium in this game. Thank you for listening.